Welcome to Aviation World.
Welcome presentation covering the fire protection system on A320 series aircraft. This lesson covers the following fire detection and protection systems: fire detection and extinguishing for the engines, fire detection and extinguishing for the APU, smoke detection and fire extinguishing for the cargo compartments, smoke detection for the avionics ventilation system, and smoke detection and fire extinguishing for the lavatories. Portable fire extinguishers are covered in emergency equipment training. We will begin with the engine systems. Each engine has its own dedicated fire detection system, consisting of two identical detection loops, A and B, mounted in parallel. These loops feed information to a computer, the fire detection unit, otherwise known as the FDU. Each engine in the APU has its own dedicated FDU. The detection loops are attached to sensing elements placed at various locations in the engine. Should a sensing element detect a temperature rise in excess of a preset limit, a signal is then sent to the fire detection unit. The fire detection unit, in turn, alerts the crew in the cockpit. In normal operations, the temperature rise must be detected by both loops before the FDU alerts the crew. A fault in one of the loops will not disable the detection system. Once the loop fault is detected by the fire detection unit, fire detection will be provided by the single remaining loop.
If both loops should fail within 5 seconds of each other, the system automatically generates a fire warning. The assumption is that both loops failed because of a burn-through caused by a fire.
For engine fire protection, each engine is equipped with 2 halon fire bottles. The fire detection system for the APU uses the same detection logic as the engines, with 2 detection loops feeding information to a fire detection unit. The APU fire protection features are also similar, with the exception that there is only 1 halon fire bottle. Like the engine and APU detection systems, fire detection for the cargo compartments is provided by 2 detection loops. Unlike the engine and APU system, these loops are equipped with smoke detectors instead of heat detectors. Cavities in the cargo compartment ceiling panels each hold 2 smoke detectors. Each detector is linked to one of 2 detection loops, otherwise a dual loop principle. The forward compartment has 1 cavity and the aft compartment has 2 cavities. An alert is generated if they detect increased particles in the air. These loops feed signals to the 2 independent smoke detection channels of the Cabin Intercommunication Data System, or SIDS. Smoke detected in one cavity activates the cargo smoke warning if both smoke detectors detect it, or one smoke detector detects it and the other detector is determined to be inoperative by the SIDS. 1 halon fire bottle is provided for cargo compartment fire protection. It can be discharged into either compartment. Once used, there is no backup in the unlikely event that smoke is subsequently detected in the other compartment. Smoke detection is provided for the avionics compartment. However, fire extinguishing is not provided. Its detector is located in the air extraction duct. Lavatory smoke detection consists of a smoke detector linked to the SIDS located in the ventilation duct of each lavatory. Lavatory smoke warnings are provided in the cockpit and in the cabin. In addition, the waste bin in each lavatory has an automatic fire extinguishing system. A small halon bottle will discharge if an abnormal heat rise is detected. Each waste bin system is independent and activation will not generate a warning in either the cockpit or cabin. This completes the overview section of this lesson. Now, let's move on to the controls and indicators. Fire push buttons for the engines and APU are located on the fire control panel on the aft center portion of the overhead panel. Both engine fire push buttons are exactly the same, so we will concentrate on just the engine 1 fire push button. The push button is equipped with a guard to prevent accidental activation. The push button illuminates if an engine fire is detected. The crew member performing the ECAM actions would raise the guard. This allows the crew member to push the push button in and release it out. The push button extends outward approximately 3/4 of an inch from the panel. The squib lights in the Agent 1 and Agent 2 push buttons illuminate when the fire push button is pushed and released. This identifies that the cartridges to discharge the halon bottles are now armed. Pushing and releasing the fire push button accomplishes much more than just arming the squibs.
Pushing an engine fire push button accomplishes all of the following items: silences the oral warnings, continuous repetitive chime, arms both of the fire extinguisher squibs, closes the hydraulic fire shutoff valve, closes the low pressure fuel valve, deactivates the IDG, closes the pack flow control valve, closes the engine bleed valve, and cuts off the FADEC power supply.
With illuminated squib lights, if the Agent 1 or Agent 2 push button is pushed, the squib cartridge fires and the contents of the respective halon bottle are discharged into the engine. The amber discharge light illuminates to provide confirmation that the associated halon bottle has discharged and has lost pressure. The test push button is used to test the engine fire detection and protection systems. It will be demonstrated in the normal operation section of this lesson. If an engine fire is detected, the following actions occur. The master warning lights will flash. The continuous repetitive chime sounds. The respective engine fire push button illuminates. The respective fire light on the pedestal engine panel illuminates. And the engine page is displayed on the systems display. In addition, the engine fire message is displayed on the engine warning display. The engine fire push button and fire light on the engine control panel remain illuminated until the detection loops no longer detect a fire. The APU fire push button, the agent push button, there is only one because there is only one halon bottle for the APU, and test push button operate basically the same as the engine fire controls just discussed. The APU fire push button operates in the same manner as the engine fire push buttons. Pushing and releasing the APU fire push button silences the alarm, arms the halon cartridge, shuts down the APU, its associated bleed valve, and its generator. An APU fire light is also located on the external power panel near the nose gear. This light illuminates, accompanied by an external warning horn, if an APU fire is detected on the ground. The APU shutoff switch push button can be used to shut down the APU. Pushing the APU shutoff push button does not discharge the fire bottle. If an APU fire is detected, the following actions occur. The master warning lights will flash. The continuous repetitive chime sounds. The APU fire push button illuminates. The APU page is displayed on the systems display. The APU fire message is displayed on the engine warning display. The APU fire push button remains illuminated until the detection loops no longer detect a fire. The cargo smoke control panel is located on the right side of the overhead panel. A smoke light illuminates if smoke is detected in the respective cargo compartment, forward or aft. The crew member performing the ECAM actions would raise the guard and push the appropriate discharge push button. This action fires the cartridge for the single halon bottle. The halon is directed into the appropriate cargo compartment. The discharge lights illuminate within 60 seconds after pushing a discharge push button. This indicates that the agent bottle has fully discharged. The test push button can be used to test the cargo smoke detection and protection systems. It will be discussed in the normal operation section. If cargo smoke is detected, the following actions will occur. The master warning lights flash. The continuous repetitive chime sounds. The respective smoke light on the cargo smoke panel illuminates. The condition page is displayed. The isolation valves for the respective compartment close automatically, and the appropriate cargo smoke message is displayed on the engine warning display. Controls associated with avionic smoke include Gen 1 line push button on the emergency electrical power panel. This push button is selected off, if necessary, when performing the ECAM actions associated with the avionic smoke abnormal. This action disconnects generator 1 from the electrical system, but allows it to continue to power one fuel pump in each wing fuel tank. The ventilation control panel contains blower and extract push buttons. These push buttons are selected to override when performing the ECAM actions associated with the avionics smoke abnormal. This action reconfigures the avionics ventilation system in an attempt to route the smoke overboard. The cabin fans push button on this same panel is also used during this abnormal procedure to shut off the recirculation fans. This is done to prevent smoke from entering the cockpit and the cabin. If avionic smoke is detected, the following actions occur. The master caution lights illuminate and a single chime sounds. On the overhead panel, the crew will notice the smoke light in the Gen 1 line push button illuminates, and the fault lights in the blower and extract push buttons illuminate. In addition, the electric page is displayed on the system's display, and the avionic smoke message appears in view on the engine warning display. There are no cockpit controls associated with the lavatory smoke detection system. If lavatory smoke is detected, the following actions occur. The master warning lights flash and the continuous repetitive chime sounds. In addition, the lavatory smoke message is displayed on the engine warning display. It is important to note that it would be necessary to contact the cabin crew regarding which lavatory is affected. This is because the message does not specify which lavatory is affected. This completes the controls and indicators section. Now that we've covered the controls and indicators, let's take a deeper look at the systems in the normal operation section. During the exterior pre-flight, you will check that the red disc near the APU inlet is in place. This is the APU fire extinguisher overpressure discharge indicator. If it is in place, the APU fire bottle has not discharged due to overpressure. Overpressure discharge indicators for the engine fire extinguisher bottles are not easily accessible and are not required to be checked by the crew. Prior to starting the APU, you must check the integrity of the APU fire detection and protection systems. First, you would want to confirm that the APU fire push button is in and the guard is down. The squib and discharge lights should also be extinguished. Advance to push and hold the test push button and see what the test of the system looks like if accomplished on battery power only in preparation for a battery start of the APU. Well done! When the test push button is pushed and held, you'll notice the following indications. The APU fire push button illuminates and the squib and discharge lights illuminate as well. This is confirmation that the detection and protection systems for the APU are operational. Now we're going to make you work again. Advance again to push and hold the test push button to see what the same test looks like once AC power is established. With AC power, not only do the APU fire push button, squib, and discharge lights illuminate, but we also get flashing master warning lights, a continuous repetitive chime, and the APU fire message on the engine warning display. Performing this test with the APU running will not cause the APU to shut down. We now move on to testing the engine fire protection and detection systems. You should first check that the guards are down and the push button's in. Since both engine systems check the same, we will do the test for engine 1 only. Now, if you would, advance to push and hold the engine 1 fire test push button. Once again, you follow instructions well. When an engine fire test push button is pushed and held, the respective engine fire push button illuminates, the Agent 1 and Agent 2 squib and discharge lights illuminate, the master warning lights flash, and the continuous repetitive chime sounds. In addition, the appropriate engine fire message is displayed on the engine warning display, and the red fire light illuminates on the engine control panel. It is now time to test the cargo smoke detection system. For a complete test, you must push and hold the test push button for at least 3 seconds. After 3 seconds, the forward and aft smoke detectors are tested separately in sequence. In this example, you will see the test occur twice. This tests both smoke detection channels of the SIDS. If the test push button is pushed and held for 3 seconds, you will note the following indications. The smoke lights illuminate twice, one for each cycle of the test. The discharge lights illuminate and remain illuminated. The appropriate ECAM failure messages appear on the engine warning display. Now, if you would, advance to push and hold the cargo smoke test push button. Be patient, something will happen. During pre-flight, you will check to see that all lights are out and guards down on the emergency electrical power and ventilation control panels. We will continue the normal operation section of this lesson by looking at some fire and smoke scenarios. While these scenarios are indeed abnormal situations, covering them is the only way we can discuss the normal operation of the fire detection and protection systems. An APU fire was discussed in detail in the APU lesson. Recall that the APU will shut down and the halon bottle will discharge automatically if an APU fire is detected while the aircraft is on the ground. The crew must shut down the APU and discharge the halon bottle if an APU fire is detected in flight. The lavatory smoke scenario has already been covered in this lesson. Because of its complexity, the avionics smoke scenario will be discussed in great detail in a separate classroom presentation. An engine fire in flight scenario was presented in the classroom session that covered emergency and abnormal procedures in Airbus aircraft using the ECAM. An engine fire detected on the ground presents a significantly different set of ECAM action steps as compared to an engine fire detected in flight. Let's have a look. The initial indications are similar to an engine fire in flight. Take a close look at the engine warning display. The action steps displayed are unique because the aircraft is on the ground. The first two action steps concentrate on getting the aircraft stopped. The next step requires you to shut down the affected engine. Advance now to perform the first three action steps.
The aircraft is now stopped, the parking brake is set, and the engine 1 is shut down. Those action steps have been removed from the EWD. If the APU were running, additional steps would also be displayed. We will see that shortly. The next step is to push the Engine 1 fire push button after lifting the guard, followed by pushing the Agent 1 and Agent 2 push buttons. An engine fire on the ground does not require that you wait between discharging agents. Advance to push Engine 1 fire push button and both agent push buttons. The remaining step is a big one. Remember, the APU is already shut down. Advance to select Engine 2 master off. Shutting down Engine 2 causes the loss of the last remaining source of AC power. Only battery power remains. VHF 1 and the P8 are still available. If an engine fire is detected in flight, the ECAM would direct you to wait after discharging Agent 1 prior to discharging Agent 2. An engine fire in flight is covered in later training.
If the APU were running when the engine fire occurred, the ECAM steps would be as you see here. In this case, the aircraft is stopped and the parking brake is set. The ECAM recognizes that when the next three action steps are completed, that is, shutdown of both engines, AC power will still be provided by the APU. This means you will still have the ECAM to guide you through the remaining steps. These steps will include guidance to orchestrate the evacuation, if necessary, and eventually shut down the APU and batteries before departing the aircraft. These steps are not shown here. We will now move on to a cargo smoke scenario. You're flying along, singing a song, and then this happens. Click forward to continue, please.
Smoke has been detected in the forward cargo compartment. Advance to lift the guard on the forward discharge push button and discharge the halon bottle. The forward cargo compartment isolation valves closed automatically when smoke was detected. You have discharged the agent into a closed environment. Remember, it takes about 60 seconds for that single halon bottle to fully discharge. Advance to see the indications when the halon bottle is fully discharged.
Both discharge lights have illuminated. This reminds you that you have discharged your one and only halon bottle for the cargo compartments. The smoke light will remain illuminated for the rest of the flight. Keep in mind that the cargo smoke detectors detect particulate matter. You have just fired billions of particles into the compartment, so the smoke light will remain illuminated. Our first system abnormal is a simple one. The FDU has determined that Engine 2 fire detection loop A has failed. This is a for info only ECAM message. There is no chime or master caution light and no action steps. The FDU now accepts the input from the remaining loop alone to alert you to a fire. In the unlikely event that Engine 2 loop B subsequently fails, a fire detection fault message is displayed. Remember, if they fail within 5 seconds of each other, a fire warning is generated. The Engine 2 fire detection fault message indicates that fire detection is no longer available for Engine 2. Here is a sampling of some of the other for info-only ECAM messages you could see. The smoke, lavatory, and cargo detection fault message indicates a failure of both smoke detection channels of the SIDS. Lavatory and cargo smoke detection is lost. Smoke detection in the avionics ventilation system is still available. The only significant difference relates to cargo and lavatory smoke detection. Some A321s have a dual-channel Smoke Detection Control Unit, or SDCU. On those aircraft, the SDCU is responsible for lavatory and cargo smoke detection instead of the SIDS. The SIDS is still installed. However, it does not have a role in smoke detection, but it does have a role in providing alert indications. For example, if lavatory smoke is detected, the signal is processed by the SDCU and sent to the SIDS, which provides an alert to the cabin and flight crew.